Okay, I think this is the last one. This is just another one of the ones we just did where I would think my gut would be I'm going to do this 1 minus sign and just do the conjugate. And usually it doesn't matter if the other side has a 1 plus sign x down on this side and a 1 minus sign on the other side, then you can kind of just pick and choose. But it seems like in these previous examples, that hasn't worked out nicely. So in the previous one, I did try to do 1 plus cos up here on the left, but it ends up needing this weird divided by move. So I ended up doing the conjugate of cosecant cotangent. Over here, the previous one, I thought I would just do the 1 minus cos, but again, it had a weird thing, this weird division rule, which I didn't even go over. So I decided to do the 1 plus secant on the left and do the conjugate, and that seemed to work. So it seems like when there is conjugates, the one that seems a little bit more challenging, secant, I should probably choose that. So over here, this previous one, I have 2 options for conjugates. I'm probably going to choose this one that's a little more challenging down here. If I go down to this one that we're doing, I've got 2 conjugate options. I'm going to choose the one on the right, just because I feel like that's probably the one. I could be wrong in this case, but that's probably the one that'll end up working out the nicest in the end. It's going to be really hard to turn something into that, so I might as well start with it and try to turn it into sine and cosine at the end. So I'm going to just try. Again, I don't know, I haven't done this yet. So I'm going to multiply by the conjugate, secant x minus tan x. And I think if I do that, I'm going to have a secant tan statement here, some obvious substitution. So is there a secant and tan one? There is. Tan squared plus 1 equals secant squared. But I'm going to write that right now because we're probably going to need it. Tan squared plus 1 equals secant squared. So there's going to be an obvious substitution. Which is tan squared, I think, plus 1 got me secant squared. So I'm going to do this. On the top, it's just going to be 1 times anything is itself. So I'm going to get a secant x and a negative tan. So secant x and a negative tan. That'll be on top. And the bottom will be a lot more complicated, though things will mostly cancel out. So secant squared, negative secant tan, positive secant tan, those will cancel, and a negative tan squared. So I have a secant squared, a negative secant tan, a positive secant tan, and then a negative tan squared. And again, those are what will cancel. So I have secant squared minus tan squared on the bottom. So secant minus tan on top, but a squared, secant squared minus tan squared on the bottom. Now, I need a secant minus a tan. So sorry, that was just the bell there. I need a secant and a negative tan. I don't have that, so I'm going to minus the tan over to here. So that way my substitution will say 1 on the left and secant minus tan on the right. So that, wherever I see a secant squared minus tan squared, I'm going to put a 1, and that's what I have. So I've got a secant x minus tan over just a 1. Now we ran into this problem previously where that looks nothing like what I have. Secant x minus tan. But if I turn them to sine and cos, so secant is going to be 1 over cos, tangent is going to be sine over cos, I can then put them together. They already have a common denominator, so on the top is just going to be a 1 minus sine x, and the bottom will just be that common cos. And that is my answer. Wow, that just barely fit. 1 minus sine over cosine.